people just coming in, I think we can officially open today's webinar. So the mic is yours. And guys, don't forget, if you have a question, just leave it on the Q&A or on the comment on Facebook. And in the last 15 minutes of the webinar, we will make sure we answer to as much questions as possible. Mircea, the stage is yours.
Well done. Welcome to another edition of our Quarantine Ember Academy webinars. We are nearing the end of a year with unexpected challenges, putting once again our anti-fragility to test. And until everything slowly gets back to normal, let's make ourselves comfortable, expand our awareness, and create a vision about how to make better games. And this is basically like the core theme that I selected for today's webinar. All right, and it's called Agile Games QA, Tailoring and Optimization. The reason for which I decided to pick up this topic is that in February next year, we'll celebrate 20 years since the Agile Manifesto was published. And in the meantime, the ways in which software is developed change a lot, and all connected disciplines have been drastically reshaped by these transformations. And some of these went more deep, some only scratched the surface. But the only constant thing is change itself. And it is us that can lead this change in our areas and push the evolution forward, taking initial action before starting to adopt new trends, and creating a framework that will help us to cope with the challenges of the future. So in this context, I'm happy to shed some light over how we can bring an agile perspective on the way in which games are tested. And regardless of what neighborhood of the game development world you might dwell, it is our shared responsibility to advance the quality of the future games. And in order to achieve this, our goal is to work on the seamless integration of all the disciplines and increase the collaboration all across the software development lifecycle. So this was the not so elevator pitch of our talk today. Let's start this presentation with a bit of introduction of myself. My name is Mircea. This is quite hard to pronounce if you are not a Romanian. Basically, it comes from the root word, Slavic word mir, which means tranquility or peace. And I actually have a background in theoretical physics. I had a chance to attend a full month studying the cosmic radiation at the largest nuclear facility in Russia, and also had the chance to attend a workshop at the Large Hadron Collider in Geneva. And I think I got in the game development industry by mistake and stayed for the fun and challenges. And I think game development is in a positive way, twilight zone of software development, where there are a few things that are really set in stone and even fewer permanent solutions. So a lot of times, every new beginning is a beginning from scratch, and that keeps an inquisitive mind always engaged. And this is what I love about the people involved in the game development process, that they all possess inquisitive minds. And when you put everyone together, you always get a fun and challenging mix to create new games. And I've been working in the QA leadership and management for 20 plus titles on PC, consoles, and mobiles, ranging from big franchises like Need for Speed or FIFA or Battlefield to small puzzle games like Ember's infamous Link Twin. And during the last 3 years, I've made a detour in product management, working in Berlin for a company that developed an automated solution for the digital publishing industry. And there, I managed to round out my expertise by understanding how the development process actually works, and also implemented a lean startup framework through which we, together with the team, we delivered the first Alexa skill, being able to deliver news brief on demand, which in German that would be Alexa Zusammenfassung bitte, which is quite fun. And what we're going to discuss today will be to provide a quick overview of the games QA world and run one-on-one comparison between like differences between games QA and software development, like or traditional software development. Then we'll investigate a little bit how we can create a full framework to support the development of games. Through what Timber we have as development support services. Then we'll discuss a little bit what kind of challenges and pitfall the integration of external QA teams can bring, and we'll try to actually mitigate and find a plan of attack and solution to overcome those challenges through an alignment model between testing and development. And last we'll have a discussion about different ways in which we can engage the QA function earlier throughout the game development lifecycle and understand better the gains that can come out of it. And at the end, of course, we'll have a 15 minutes question and answers session for any questions that might pop into your mind. Like as a brief homework for you guys, I would ask you from the outset to think about 3 attributes of the most unloved game that you ever played.
And I think if you guys want, it would be a perfect moment to like use the comments in Facebook as to complete this. And here on the chat, you can just add whatever you're thinking. So if you have things, these 3 games in mind, share it in the comments on Facebook or on the chat.
Sounds great. And as a follow-up, based on all the attributes in the months to come, I'm going to try to create a white paper and determine how exactly QA could prevent or could have prevented those problems in the first place, based on all the knowledge that we now have about how to test games better. Now, let's see exactly why is the game development of a game slightly different than the development of a normal app. So to begin with normal software applications, the developers want the users to be able to quickly identify exactly how to obtain the desired results. So that means that the most successful software allows the user to load the program and understand how to resolve a problem with as little searching and exploring as possible. Now, most applications will react in the same way each time a user does a specific series of actions. And these products are meant to perform the same function reliably. So that means that once a problem is found, there is a high probability of recreating and fixing it, which makes things quite easy both for the developer as well as for the testers. Now, on the other hand, in games, all information is purposely hidden from the user, thing that makes games fun and worth exploring. Now, a game is a software designed to give the user the least amount of access to the actions of the programs as possible, or at least during the beginning phase. So game designers want the player to have no choice but to take time to explore the world and discover what the game actually does. So they do this in order to preserve the mystery of the world, the quest, and the fantasy. The harder it is, the more time it takes for the user to obtain the so-called desired results. So basically, a game is an enormous and highly complex database with a shell that is built to obfuscate the purpose from the user. And it is designed to be unpredictable. Events don't always function the same way twice. And things don't get easier when we add to this mix some artificial intelligence that will actively try to outsmart the users. And because of this, the whole testing process and the testing approach is slightly different than from what a normal software tester would do. Because as a game tester, you are interacting with an intentionally limited interface that is constantly changing the way it functions as well as the way it looks. So it can be nearly impossible to know if what you see is what you're supposed to be seeing. And I called here a couple of the core differences between the game development and the normal software development. And the first one is the extensive demand for creativity and artistic impression. And one of the reasons for this is that many of the game developers do not consider themselves strictly as working in the software business. In a lot of organizations, even developers doing programming consider game development as creative work rather than normal software engineering. And games are just interactive art. They're fully comparable to movies. Being involved in a creative endeavor involves a tiny adjustment, even to the hard disciplines involved. Now, the next particularity would be the fact that, for the most part, games are way behind the rest of the software engineering world when it comes to automated testing. And a primary factor is limiting budgets. Test automation strategies require a significant upfront commitment and funding that at this moment is hard to be attained by indie and mid-sized publishers. And in games, there are two main ways to handle automation. And one way is hooking its way into the game, where you need some engineers to create entry points for that, so the so-called hooks. And this is an intrusive way because you need special debug capabilities, allowing to hook in and manipulate functionality. Now, introducing this kind of alien system inside the software might not really mirror the way in which real users would likely interact with the game. The other way is through the so-called screen-based detection tests, which are also hard to implement because games don't have a really deterministic behavior. So if interactions are randomly generated, then the same action won't always return the same results. And this accounts for virtually unlimited ways of interactions that makes the design of an adequate automation infrastructure extremely tedious. As far as I know from the public reports, one of the greatest stories regarding automation for games is the structure, the build verification system that Riot implemented for League of Legends. And their current reports advertise the fact that approximately 50% of all critical or blocking bugs are discovered in-house by these automation systems. But nevertheless, 50% still leaves half of the work to be carried out by the QA people. Now, the third thing is that game industry has been moving rather slow from the so-called creative chaos and ad hoc practices. There is 2 out of 10 chances that the boss will be transformed into a rubber deck after the third punch. Then obviously it is super hard to get this kind of behavior implemented through a software solution. And the last important difference here is that interactions with the other disciplines of the game development world also creates new challenges. Oftentimes, artists have a creative process which is not clear for programmers, and working together on building the intangible fun factor and artistic expression is an app requires a lot of error and trial, which cannot be really contained by any traditional game development framework. Now let's try to dissect a game and what exactly makes or breaks a game, or like the success of it. And usually whether a game will survive or not boils down to three things: buggy games and bugs and games that have like improper functionality will almost always fail. Then the games fail because they can simply be boring. And the third reason for that is that sometimes, although there might be flawless from a functionality perspective, or have an increased fun factor and immersion, they might still not have the monetization system that would allow the publishers to support its maintenance. And at the core of any assessment regarding the quality of games, there is obviously the foundation, which is flawless functionality, and users always need a reliable software. The next is the user experience. And users are extremely sensitive to usability issues, especially the gamers. There are hundreds of menus and settings in a normal game, and users need to figure out how to get the basics right in a relatively steep learning curve. So if you can't figure out in a relatively short amount of time how to use something, we might end up not using it at all. Now, the third aspect, and this is one of the most intangible ones, is actually the immersion. And immersion and getting into a sort of dreamy flow state is probably the part that qualifies building a game as an art. I only want to remind everyone at the same time that we are also seeing a transition from the millennials to the Generation Z, which is a digital native one. So the expectations of the new generation of users in regarding to player experience and immersion are greater than everything that have been in the past. And at the top of the pyramid, obviously, we'll have the monetization system. So basically, if the foundation is not working, there will be no successful games, and that is functionality. If the functionality works, but the users can't figure out how to actually use the game as a product, then the game will fail once more. If the users can figure out how to use it, but the player experience is not immersive enough, then obviously users will decide to move on to the next game. And on top of everything, there needs to be a smart monetization system in place in order to make the business profitable from a business perspective. And now I think we can analyze a little bit how a normal game is structured from a technical perspective and see again what are the differences between testing software and testing games. And the first thing is the game as an app. And here, besides all the functional stuff that needs to be tested, there are some areas confined to the expertise of the game testers. And that is the fun factor testing. And for instance, unlike other kinds of software, games must be fun. When you have a payment module in place, the payment module doesn't need to have any kind of fun factor, but games must be fun and immersive. And in order to be able to break down the fun factor into actionable test cases, you need large domain knowledge of games, which is actually what you'd find in a solid games QA team. Then a game needs to be balanced. So there is a lot of balancing testing going on during the development of a game. And there is the balancing of levels, the balancing of difficulties, the balancing of weapons, boosters, or equipments, and the balancing of different character options like race, class, attributes. On top of that, there is AI testing with different attributes of an AI and how it reacts in different situations is absolutely critical for the success of a game. How well it mimics human behavior, it's a hot topic. Another one is the survival instinct, because the AI needs to look for cover in a firefight. And it also needs to get into a hunting mode and not only react to players' actions, but proactively devising an attack tactic. Then is pet fighting. And I think that this sums up all the particular kinds of testing that would be added up to the normal functional requirements that you test when considering the game as an app. Besides that, we need to consider that a lot of games have physics engines which affect both gameplay and animation. And now many of today's mobile games are based on open source commercial games engines such as Unreal, Unity 3D, CryEngine, and so forth. And with this, there are two main things that require extra attention, and that is the game level and world testing, because a high number of instances where assets are used in a normal app. No, actually, a normal app might use the same asset in maybe 5, 6 menus, but in a game, you'd have the same asset reused in maybe 100 plus different instances. So that means that the test team must find all the instances where those assets are found and test them for missing geometry, for holes, or sticky spots. Besides that, the physics need to be realistic. No matter if the game is taking place in a world that is simulating our universe and obeying the current physics of law, or in a different universe with a completely different physics, the breakable geometry and the dynamic behavior need to be consistent with the behavior of and the laws in that universe. Now, the third thing is the platform testing part. This can range from mobile platforms to console platforms, and there is a lot of investment carried out in providing compatibility testing. It is not enough that the game would run on the latest iPhone, but you also need to ensure that the game is launching correctly and it provides a great user experience on your grandma's iPhone 5, or on for those people that might still be using the Internet Explorer versions. Now, the third part, and this one critical aspect, especially for monetization for the current generation of games, is the backend part, where testing notifications and advertisements and live ops is absolutely critical in order for the monetization of the game to be successful. And obviously, the last part is the connection. Now, even though other kinds of software communicate with other users and servers, it is often, to a lesser extent, less sensitive than what happens in a massive multiplayer online game. Now, most of the games, mobile games today, have a server-client interaction requiring a login, an uploading of data, and downloading of data. So this makes room for a lot of game-specific types of testing, depending of the multiplayer interactions being synchronous or asynchronous, considering network stability, failed connections, lagging issues, scoring updates in leaderboards, or invisible players. And it would be great if you think what was the nastiest connection bug that you encountered recently. Now, to sum everything up, I think the biggest challenge is that the game development and game testing world has nowadays are the fact that there is no industry testing standards. There are lots of books regarding professional game testing and designing QA processes, but most of these results are based on the experience of people that worked in the QA department of big publishers during the last 20 years. And the thing is that most of these best practices doesn't represent a real industry standard, but rather a set of reactive measures that proved successful for past games. But there is no actual guarantee that any of these would work for challenges that the new generation of games brings along. Then test planning and design are not a structural engineering type of science. Obviously, even now, designing a test strategy, it's halfway in between having like a rigorous mathematical science behind it, and being an art where you need to consider all the constraints that are typical to creating a successful game. And last part, and this will bring us to the topic of agility, is that the relationship between development and QA didn't really evolve much beyond the sequential link of the software development lifecycle. And we'll get back to that in the next slides. Now, considering all this huge environment of game testing and the large number of tests and scenarios that need to be covered before a game is released, we now focus not only on classical quality control, where you'd have testers just button mashing and trying to find the bugs with minimal documentation, but we have a complete revamped way to tackle the QA process. And I can give the example of Amber, where we are a game development agency with the mission to set the games industry standard in development services, and we also have an integrated model for development support services, considering the QA process as a strategic responsibility. When considering quality in the context of game development, there are 4 dimensions that one needs to take into account. And the first one is the relationship between QA and development teams. And QA needs to constantly provide value for that. And in order to do so, we here take ownership of the end-to-end testing process, allowing dev teams to concentrate on core innovation and development, and providing bug reports with all the information that would allow the dev team to understand the bug as fast as possible. Then there is a shared responsibility of quality assurance to create value for the end users. And we actively represent the voice of the customer and the user needs, striving to create user-centric test strategies. And this is one of the hottest topics that this presentation, I hope, will support. The one that we always need to design a user-centric games testing strategy. Then we always team up with partner dev QA teams, sharing expertise and creating an unbeatable QA partnership committed to evolve the quality of games. And last but not least, we always look at the game from the bigger picture and fulfill the testing needs associated with the game, being not only an entertainment solution, but a product, and thus supporting the business objectives of our clients. So in order to navigate a little bit the labyrinth of different sub-disciplines of gaming QA, we can talk about the mobile games QA and also having expert embedded QA testers that can support the development teams during the pre-integration phase and in the early phases of the project with any kind of technical challenges and ad hoc requests that might come along. We represent the voice of the customer through customer support and ensuring that all the information that we get from the users is fed back in the development process through having a dedicated product strategy in order to improve the defects reported, as well as for business in order to understand what the users actually wish. Then we also have a live monitoring when we can, based on the analysis of usage data and how the end users are actually using the app, determine what the best solutions would be in order to level up the quality. And we also have the specialized Apple, Android, Sony, so first-party testing that makes sure that the apps are ready for submission with minimal risk of being rejected during the first party assessment. And my favorite one, which is the benchmark kind of testing. And here we take an unreleased game and we measure frame rate, GPU utilization, CPU, network usage, battery consumption rate, and temperature, and plot the values measured for the game against competitor games that are already live in the app stores. And I think the funniest kind of test that Gaming QA has developed is using an infrared thermometer in order to measure the temperature increase after prolonged gameplay. Now, in terms of the way in which the classical software development cycle is applied when developing a game, it is in 75% of the case a cool concept being designed by a bunch of designers and producers through pre-production and brought to the state of a relatively functional prototype. After the prototype is ready, we have the implementation phase where the artists and the programmers are onboarded, and the game starts to gain a critical mass and makes fast steps toward release. Well, now it is usual in this phase, like halfway through the implementation phase, when the first plans regarding quality assurance are being made. And this leads to the test phase coming in the post-production after almost the whole game is being developed, and having external QA focusing on bug hunting, while all the programmers are focused top-heavy on fixing the bugs. And there is a major flaw in this model. Because when considering how the cost of quality evolves in this model, we need to consider that the cost of quality is always broken down in the cost of good quality and the cost of bad quality. And the cost of good quality has two components: the cost of prevention, where you normally find any upfront investment in an automation strategy. You have automated code review processes, maybe strategies for containing technical risk, but also design testing. And then there is the appraisal cost, which actually translates in the actual quality control cost, where you have professional testers testing the game. By the same token, the cost of poor quality has also two components. And one of these is the internal failure cost, which amounts to the overall costs in fixing the bugs, as well as the external failure costs, that are the bugs that degrade the user experience and make user quit playing the game. And normally, with in a good planning framework, the strategy for tackling the development of a new game should have a balance between the cost of good quality and its two components, as well as the cost of bad quality and its two components. And now the problem is that the later you bring on the quality team, and the later on you start detecting the critical bugs, the relative cost to fix bugs is increasing exponentially through each phase of the software development lifecycle. Just to add some numbers here, the worldwide software failure cost reached in 2016 around $1.1 trillion. And oftentimes there is no way around. So basically, if you delay the onboarding of the QA team till the late stages of the development, and there is virtually no QA professionals working on the game before, not only that the costs are increasing for detecting and fixing the bugs, but also the technical risk. Because if any kind of agile framework is based on a loop structure that includes several loops feeding back into each other. What we would see in a typical 3-sprint release, let's say after the game was released and new features are developed, is that usually during the first sprint, the code is being written, so developers are working on feature development, and sometime in sprint 2, the first case tests start during the pre-integration phase, and they mostly have an ad hoc structure. And then it is in sprint 3 when QA takes the stage, and we have a full team of professionals focusing on integration and regression tests. But now the biggest risk with this approach is that you will have most of the bugs discovered and fixed towards the end of the software lifecycle. And fixing a lot of bugs shortly before the release increases enormously the technical risk and the probability that knock-on bugs will be triggered by each bug fix that is made. And in order to mitigate all these issues, one of the most solid approaches would be to design an alignment model between the development and the quality assurance functions. And usually end user satisfaction is the top objective of any quality endeavor. So the end result of the work of all disciplines is having some happy end users that love the games. And in order to get those happy users, we need to account for testing strategies that aren't functional centric, aren't requirement centric, but are 100% user centric. And normally, when considering the game as a product, we always start from the user needs and from a product strategy. So there are some users identified, like some sort of hardcore players that would definitely play certain kinds of games. And then there is the publisher's business strategy that would consider transforming those needs into a functional product. But in order to get the functional product, you need a development strategy in place that will ensure that the code is written and the product is actually delivered. And in order to have the product delivered and a functional software system, you need a QA strategy in place that is able to ensure that what will reach the users is a high quality game. Now, the development strategy and QA strategy are the key pillars of the product strategy, which converts the user needs and business strategy into a user and business value. And full alignment of these pillars is necessary in order to ensure that a joint action is in place between all disciplines with minimum waste. And a key prerequisite for this is to ensure that throughout the whole business value generation chain, information can be decoded identically between all disciplines. Because when we think at this diagram, on the one hand, we have business and product people that mostly talk numbers and money. And then we have the development people that would mostly talk in terms of code, in terms of design. In the third part, we would have the QA strategy and the QA people that would talk in terms of bugs. And in the middle, we have the user that would just think, well, today I'm bored and I need a fun game to play. And it's extremely important to ensure that, and in order to build a shared vision about how the users can become happy with a fully fledged functional product, all disciplines are using the same language. So information is passing through four important strategic nodes. And that is the producer, that is the design lead, that is the engineering, and the QA manager. And it's important to ensure that everyone is on the same page. And based on this alignment model, it is absolutely critical that in order that, well, in order to remove any kind of issues and differences between all the disciplines, the alignment model involves the synchronization of the working cycle and provides a common denominator between having a flawless development strategy, a great case strategy, and synchronization between the development capabilities and the QA capabilities. And having a strategic alignment in place at the start of the project and running through the execution phase ensures that all the teams are running into the same direction. And in this ideal model, we would have the user needs, user types, and user behavior at the start of the value generating chain. And in the prototyping phase, these would be transformed into business requirements, use cases, and user acceptance tests through the help of QA professionals. Now, further down the line, the business requirements would be broken down into design specs and technical specifications, and finally into QA test cases. And this is done by the collaboration between product, design, engineering, and QA. And the result here is that in the end, we have a user-centric strategy that converts the user needs throughout all the phases of the product development into some meaningful outcome. That can be bugs, it can be test cases, but also a qualitative assessment of the business hypothesis that supported the development of the product in the first place. And this happens exactly into a left shift QA process that pushes the QA involvement in the earliest phases of product development. And the rule of thumb here is that if the acceptance criteria are broken down at the start of feature release into some test cases that can facilitate the qualitative assessment of the product hypothesis before production deploy, feedback can be provided before the actual release, allowing for last-minute improvements that can boost up the success of the final deployed product. At the same time, this reshape of the QA involvement scheme is also maximizing the output of the QA function through the early involvement and alignment of the testing and development activities. And now, lastly, there are a couple of ways in which the QA function can be integrated earlier in the development lifecycle. And usually the traditional format for mass QA is having the super tester A involved in the last phase of the cycle, which is the phase where we have some granular test cases defined, we have some release candidates built, the testers are focusing on hammering down any kind of functionality issues, but they have a minimal understanding of the designer requirements, of the technical architecture, and the business rationale behind what they are testing. Now, as the name implies, in the single tester model, super tester A is involved in all stages throughout the release. This has the advantage of continuity, as one person begins learning about the business requirements from the very beginning and continues building knowledge through each stage. The disadvantages of this model include the over-dependency on one person and the expectation that this person must be well versed in a wide range of skills, ranging from requirements analysis to specialized functional testing. Now, another risk, obviously, is that of bottleneck or overload, because especially when there are no additional QA available. The second model, it is a bit more balanced, but not 100% balanced. And here we would have one tester, super tester A, that will work with all aspects of the project, including the design, specification phase. Then tester B will join in the detailed design stage and be responsible for testing till the release candidate is delivered. Now, in this model, this is the most common embedded QA model, where we have a super technical tester that works together with the development team in the pre-integration phase, and we have a slightly generalist tester in the last phase, working on mostly on functional test cases. And then there is the last model where we would have two testers with a slightly different kind of specialization. We'll have the first tester that would be working as a product analyst, will be involved in the development team, understand the tech requirements of the product, and then be able to break down the design requirements into some criteria that can be tested by a QA team. At the same time, there will be virtually no knowledge transfer required because the tester B would also join in the design requirements phase and will be able to cascade the knowledge into defining the high-level test cases and granular test cases that will support the release candidate testing. So if you would take three takeaways from this discussion, the first thing is that if a team believes that they are agile, but there is virtually nothing changing in regards to the testing process, there is still a lot of learning ahead. Then ensure that design people and QA people know each other and agree on methods of collaboration as of day one. And consider involving a QA person, maybe even as a temporary assignment, to help the product team during the discovery and prototyping phase to break down these criteria into test cases that can be validated by QA. And this was most of it.
Thank you, Mircea. And yes, we do have questions. So we have 5 more minutes left. I'll select some of them for you to answer. And thank you guys for being here with us and for being very interactive on the chat and asking questions. So there's one very interesting, Mircea, and it's with a bit of a comment. So here it goes. I would imagine that AAA games like the Assassin's Creed and the Cyberpunks are impossible to be QA automated. How far along are we from automating QA on games featuring more simple mechanics like match-3S? What do you think?
Well, considering the industry reports for Disney, for instance, there have been approximately 17-degree penetration rate for test automation for match 3 games. So this is the current state of things. I expect that we are nearing a revolution in regards to the way in which we are doing QA, especially through using AI and machine learning to get some bots navigating through the app and simulating user actions. But yeah, basically we are now under 20%, and that happens only in big companies that can actually allow investing upfront into automation.
Cool, that's great to know. And there's one more that I would like to ask you. It's about the fact that several games titles have been deemed rushed or lacking polish, Cyberpunk being the most notable. Has the pandemic affected QA efficiency by messing with team alignment and information flow? You said a lot about information flow and the need for alignment, so let's see. Has it affected it?
Let's break down the question into two parts, whether the pandemic affected the industry and the level of collaboration overall, or if rushing the game was a consequence of the pandemic.
Let's take it one by one.
I would say that considering the traditional way of doing things and having the QA slightly separated from the rest of the team, joining in the late phase of development and trying to figure out the requirements as soon as possible in order to be able to test efficiently. The pandemic didn't have much of an effect in terms of speed of execution or the QA process overall. In terms of rushing the release of a game, this obviously a business decision where sometimes QA might not be involved at all.
That's great. And there's one advice that some from the audience here is asking you, and it's about the upgrade of the level of a tester. From your experience, because you've seen multiple teams, you've coordinated multiple QA teams. What would you recommend besides the actual experience of the tester? What would you recommend in terms of improving knowledge or skill set for a tester to level up?
Well, I think there are three key areas of improvement, and one is the product knowledge and trying to understand the business rationale behind the features. For instance, sometimes if a level is too hard, and that level and the fact that it is hard makes users leave the game and affects engagement, the producer and the game team would decide to add some extra balance. So the QA people need to understand what is the reason for the changes that appear in the game and what was the intent of these modifications. And this way they can get a better image about how that feature would impact or is expected to impact the end users. The second part would be increasing the technical understanding of the game. It is not enough to stick only to functionality, but rather having a deep understanding of the software architecture behind it, because only in this way you can develop a sound strategy for finding in-depth bugs.
Thank you, Mircea. And I see that questions are still coming in. I will just make a note of these questions and maybe we comment on the Facebook page with more comments because our time is up for today. Thank you so much, Mircea, for sharing these insights with us. We needed something. Yes, indeed, we needed something on quality assurance as well to end up and wrap up the webinars that we had so far in multiple disciplines. So it's been quite a few topics for us that we shared with you guys in our Ember Academy live webinars. We hope to see you next year as well with more insights and more topics from Amber people. And not only, we also have guest speakers to share know-how with you. Stay safe, have happy holidays, and thank you for being here with us.
Hey, thanks everyone. Stay healthy.
Stay healthy. Bye guys. Bye.